In the previous video, we began working through the steps necessary to plan the sample size for this big 5-vignette study. So recall that we created 100 observations based on a particular distribution that we defined, and then we ran the pattern analysis cross-ordering procedure, saved those randomized PCCs from the randomization test, and then looked to see how many of the PCCs fell within the closeness range, which is based on the closeness proportion, and it was only 74%. So we need to boost the sample size and go through that process again to hopefully get something closer to 90%. So I'll cancel out here, and let's go ahead then and create another data set. Generate random observations. Everything is all set up here. Notice the proportions are the same, so that's all good, but we need to now bump this up to, let's go with 200 and see what happens. So we'll double it. So now we have 200 observations, as you can see here. Just need to then run the analysis. So analyses, pattern analysis, crossed orderings. Put these over. Let's make sure we're working with that's the most recently generated data set. Oops, by clicking that, it took them away. And now we need the expected pattern. Go and take a look at the observations. Again, it looks fairly randomly shuffled there. And now we get the randomization test, save those randomization results, select OK. Iterate through, have a new data set created here. Go to that data set, and here it is at the end. So these are, didn't select it there, sorry. Here it is. So here are the new PCCs for 200 observations in the sample size for the study. So now we need to get the mean for these PCCs. Turns out to be 35.54. Go back to the data set here. Now we need to work within the distribution. Just auto-generate here just to create 3 quickly. I can work with. Now I can work with these. Again, what was my mean? 34.54. So working with this middle unit then, 34.54 minus 5 is 29.54. And then 34.54 plus 5 is 39.54. Again, so that is our closeness range based on the closeness value of 5 PCC units. And now we need to make sure there's no overlap here. So 29.54, just a smidgen below that is 29.53. These would be the low PCCs. And then we'll go to make sure there's no overlap here, 39.55. And this is the high unit. What we're really interested in is that middle unit there. So I'll select distribution. And we have uncategorized observations here, 30. So I've made an error here. Something's gone a little bit wrong. 25 to 29, 3, 39. Oops, there it is. I'm sure you probably saw it. So there we go, 39.55. Let's update it. And now we have some uncategorized observations. Let me go and expand this out. Again, what's probably happening here, because I've taken away the overlap completely, probably I don't have enough decimal level precision since I've entered it in as 2 here. So I need to go ahead and change that to 2 decimals and hit enter. It went to the top. Let's go back to that ordering. And so there you have it. So that fixes the overlap or error there. So it always pays whenever you're working in this window, not just for this type of analysis, but for anything that you're doing, when you're working within this window, make sure that you're looking at the information you're getting here, the number of units, number of observations, make sure that everything and everyone is accounted for. So here we are good to go. And now most importantly, we can see here the closeness range based on the closeness value. We get 880, that's 88%. So pretty darn close to that 90% desired value, that closeness proportion. So it's up to you at this point, or up to us, I should say, at this point, is this close enough? We'll just go with 200, or should we go ahead and bump it up to maybe 220, perhaps 250? We continue to bump up that sample size. We're going to get closer to that 90%. But for any particular research endeavor, this may be close enough. It's really up to the researcher to know when to stop. It's not an exact science. It's just a way of trying to plan your sample size based on that randomization test, following the spirit of the a priori procedure.